Okay, so number one, we're just wanting to identify if we have exponential growth or decay, and in order to figure that out, you have to look at your base. So your base is always going to be the number that's raised to the x power. Now, if the number is less than 1, which is what you see here because it's a proper fraction, you're always going to have decay. Okay, so looking at number 2, this is your base because it's raised to the x power, and you've got 6/5. 6/5 is 1 1/5, so we know that that's greater than 1. So this is going to be exponential growth. So when we get to problem number 3 and we're having an exponential function that we're asked to graph, look at your base. You see that your base is 3. So since your base is 3, that's going to be exponential growth. All right, so what we're going to do here is we're going to take our function and we're going to write down our x and our y values. Now, we started using the same 5x values every time. However, when you add and subtract inside the function, that's going to shift your x values. And so since we have x plus 1, we know that every x value we're going to take that and move it 1 to the left. So since we're doing that, let's take all of these x values and shift them 1 to the left. So -2 minus 1 is -3. -1 minus 1 is -2. Okay, 0 minus 1 is -1. 1 minus 1 is 0, and 2 minus 1 is 1. Okay, so this will give us our new x values. So let's take and plug those in. So we'll have -3 plus 1, which is -2. So I'm going to very quickly plug these in here in order to save us time. So again, -3 plus 1 is -2, so that'll be 3 to the -2 minus 6. So you'll get -5.8 repeating. Okay, then you'll have -2 plus 1 is -1. That'll give us -5.6 repeating. You see how close these are to our asymptote of -6? Then you have x is -1 plus 1, which is 0. Anything to the 0 power is 1, and 1 minus 6 is -5. 0 plus 1 is 1. 3 to the first power is 3. 3 minus 6 is -3. Then we have 1. 1 plus 1 is 2. 3 squared is 9. 9 minus 6 is 3. I think I'm going to go ahead and just add the 2 just to see what it does. 2 plus 1 is 3. Okay, we have 3 to the third power, which is 27, and 27 minus 6 is 21, so that was too big, okay? So now let's take these 5 points, because I won't be able to graph this bottom one, and let's see what we've got here. So we have our asymptote, which we know is going to be this number right here, which is -6. So I'm just going to put a little dashed line there to represent my asymptote. So I have -3 and -5.8, that's almost -6. And then -2 and -5.6, that's just going to be a little bit higher. And then I have -1 and -5, 0 and -3, 1 and +3. And again, that 2 and 21 is just not happening. So you see that we're going to hug this asymptote, in theory, getting closer and closer to -6 without actually being -6. Okay, and so this is going to be our function right here, okay? So what we have is a domain of all real numbers, and you can clearly see the exponential growth going on right here, okay? All right, and our range is going to be y is greater than whatever your asymptote is. So since our asymptote is -6, we're going to be greater than -6. Now let's look at our end behavior. As x is approaching positive infinity, so as x is getting bigger and bigger and bigger, what's happening to y? Well, we see that it's going straight up. So that means it is also approaching positive infinity. Then as x is approaching negative infinity, that's what's happening as you go to the left, okay? And you see that it's getting closer and closer and closer to your asymptote, which is going to be -6. Now, as far as your y-intercept goes, it's going to be right here at -3. And then your asymptote, of course, is going to be a horizontal line, y equals -6. And remember, if it's an exponential function, your asymptote is going to be what's added or subtracted outside the function because it shifts it up and down. So that'll shift your asymptote from the x-axis up and down. Okay, and so that is our first exponential function. And again, this is growth because as you read it from left to right, you see that it rapidly starts to rise. Okay, on number 4, looking at my base, we see that it's 1/2. So this is going to be decay. This is going to be my asymptote. So again, with our x values, we know that we like to use -2, -1, 0, 1, and 2. However, this function is going x minus 5, so it means it's moving 5 to the right. So I'm going to add 5 to all of my x values. Okay, and then I'm going to plug it in and get my y values. So when I have 3, that's 3 minus 5, which is -2. If you have 1/2 to the -2, that's the same thing as having 2 squared. So 2 squared is 4, 4 plus 2 is 6. Okay, on the next one, 4 minus 5 is -1. 1/2 to the -1 is the same thing as 2 to the first power, which is 2. And 2 plus 2 is 4. 5 minus 5 is 0. 1/2 to the 0 power is 1. 1 plus 2 is 3. And then we have 6. 6 minus 5 is 1. 1/2 to the first power is 1/2. And then 1/2 plus 2 is 2.5. Okay, 7 minus 5 is 2. 1/2 squared is 1/4. Plus 2 is 2.25. Okay, and if we went one more to 8, that'll be 8 minus 5 is 3. 1/2 to the third power is 1/8. Plus 2 is 2 1/8. Now, if you have 1/8, that's going to be 2.125. And we can see it's getting closer and closer and closer to our asymptote, which is 2. So I'm going to go ahead and put a dashed horizontal line representing my asymptote at +2. Okay, so we have 3 and 6, so that's over 3, and up 1, 2, 3, 4, 5, 6, and then 4 and 1, 2, 3, 4, 5 and 1, 2, 3, 6 and 1, 2.5, and then 2.25 and 2.125. Now, if I were to go ahead and go over here to 2, 2 minus 5 is -3, which is the same thing as 2 to the third. That'll be 10. So that would be 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could at least get to the top of this. So as we draw our line, it's getting closer and closer to that asymptote, which is 2. But if you read it from left to right, sorry about that, you can see how this is decreasing. That's why we know it's exponential decay. And also it's approaching that asymptote of +2. All right, so as we look over here to figure out all this information, our domain, once again, is all real numbers. Our range is going to be y is greater than whatever the asymptote is, which is +2. Okay, looking at our end behavior, as x is approaching positive infinity, that means what's happening to the right. Your y value is actually approaching your asymptote, which is 2. Now, as x approaches negative infinity, that means as we're moving to the left, what is y doing? Well, it's going straight up, which is positive infinity. Now, as far as our y-intercept goes, you can see from your table you don't have that. So what we have to do is we have to go back to our function and we have to replace x with 0. So what we end up with is 0 minus 5, which is negative 5. So 1/2 to the negative 5 is the same thing as 2 to the 5th. So 2 to the 5th is 32 plus 2, which is 34. So that tells me that my y-intercept is at 0 and 34. So if you make your table of values and you have to shift it left or right, and you don't have 0 as one of your x values any longer, then the only thing that you have to do to actually find your intercept is to replace your x value with 0 and work it out. Now this, of course, would be way too big for us to find on our graph, correct? So what we would have to do is just plug it in and know what it is, but not actually graph it on our graph. Now our asymptote is going to be y equals whatever is added or subtracted outside the function. So that's going to be y equals 2. And that's going to be our exponential decay function. Now on number 5, what I would like to do is I would like to find the exponential function and I would like to find the logarithm. Okay, so I'm going to get a piece of paper here and I'm going to take number 5 and I'm going to find the inverse, which will be my exponential function. So to find the inverse, what you'll do is you'll take your y and replace it with x, and you'll take your x and replace it with y. And then from there, you solve for y. So to do that, let's first get rid of that minus 3 by adding 3 to both sides. Okay, now to solve for y, we're going to have to get rid of our logarithm. So we're going to have to change from a logarithm into an exponential function. So we're going to use the log loop. So from our base 2, we're going to do 2 to the x plus 3 is equal to y. And so now we have y is equal to 2 to the x plus 3. So for this one, let's go ahead and do our original x, -2, -1, 0, 1, and 2. Since we have our function shifted left and right because we're adding 3 inside the function, plus 3 means we're shifting to the left. So let's subtract 3 on all of these. Okay, so we'll have -5, -4, -3, -2, and -1 as our new x values. Okay, and so since I need an intercept, let me go ahead and put 0. All right, kiddos, so now I'm going to find my y. So if I plug in -5, -5 plus 3 is -2, which will give me 1/4. Okay, -4 plus 3 is -1, which will give me 1/2. -2 plus 3 is 1, which will give me 2. That was -3 plus 3, which is 0. Anything to the 0 power is 1, so that's a 1. Sorry about that. And then -2 plus 3 is 1, which gives me 2. And then -1 plus 3 is 2, which gives me 4. Okay, so I've got 0.25, 0.5, 1, 2, and 4. Now if we plug in 0, 0 plus 3 is 3, which will give me 8. Okay, so this is going to be my exponential function, and I'm going to graph that in purple. Okay, so I'll have -5, 1, 2, 3, 4, -5, and 0.25, -4 and a half, -3 and 1, -2 and 2, -1 and 4, 0 and 8. Okay, and so this is going to be what my exponential function looks like. Now, as far as my domain goes, we know that it's all real numbers. My range is y is greater than 0 because nothing's added or subtracted outside the function. For end behavior, as x approaches positive infinity, okay, right here, we can see that y is also approaching positive infinity. As x approaches negative infinity, which is over here, we can see that f of x is approaching 0. My y-intercept is at 0 and 8, and my asymptote, since there's nothing added or subtracted outside the function, is y equals 0. Now, I'm going to use green, and I'm going to put y equals x on here so you can see the reflection. So this is y equals x, and remember, when you have inverse functions, they should always reflect across the line y equals x. I'm just going to leave this as a dotted line so you can just see it. Now I'm going to do my inverse function with this pink marker or pen. So I've already got the x and the y right here for my exponential function. So to find my logarithmic function, I'm just going to take x and y and I'm going to switch them. Okay, so everything I have over here on the right side, I'm now going to put on the left. So 0.25, 0.5, 1, 2, 4, and 8. And then everything I have on my x, I'm going to put on my y. -5, -4, -3, -2, -1, and 0. So now I'm going to plot all of these points. I'm going to have 0.25 and -5, 0.5 and -4, 1 and -3, 2 and -2, 4 and -1, 8 and 0. Okay, and so now you can see the reflection across y equals x. Okay, now let's see what's going to happen with our domain. Okay, the domain of my logarithm is going to be the range of my exponential function. So that tells me the domain is going to be x is greater than 0 because the range was y is greater than 0. Okay, now my range of my log will be the domain of my exponential function, so it's going to be all real numbers. My end behavior will be the opposite, or the switch, of the end behavior of my exponential. So right here we have as x approaches positive infinity, f of x approaches positive infinity. So both of these will stay positive infinity. But when x approaches negative infinity, that will become y approaches negative infinity. So y approaches 0 will become x approaches 0. And you can see right here, as you are going down, you're getting closer and closer to x equals 0. All right, you're going to have an x-intercept now instead of a y-intercept. So 0 and 8 becomes 8 and 0. And your asymptote will no longer be a horizontal line, because when you were doing your exponential function, your asymptote was right here at y equals 0. Now that you have a logarithmic function, it's going to go from a horizontal asymptote to a vertical asymptote, which will be x equals 0. And so this is your exponential function. This is your logarithmic function.